Good afternoon, everyone. Today we're going to do 7-3. We're going to graph some logarithmic functions. So my first function that I want to graph is y equals log base 3 of x. Graphing logs is a little bit challenging. What I find easier is to change it into exponential form. So the 3 is the base. So let's do our drop and swap. So the base is what you drop, and then the y and the x, they trade places. So y equals log base 3 of x, and 3 to the y equals x. These are equivalent. One shortcut that I learned a long time ago is that in this particular instance, I find it easier to put values in for y. So since the y is the exponent, I can put any number in there that I want. So I'm going to choose values from -2 to 2. And so 3 to the -2. So 3 to the -2, you can put it in your calculator, or remember that if you have negative exponents, 3 to the -2, you would send that downstairs and then square it, so that's 1/9. 3 to the -1, negative exponents, you send it downstairs, so that would be 1/3. 3 to the 0 is 1, 3 to the first is 3, and 3 to the second is 9. So these are the values that we're going to graph. So estimate going over 1/9 and down 2. Estimate going over 1/3, down 1, 1, 0, that's a point right there. 3, 1, and 9, 2. So if you connect the dots and finish sketching it out, you would get a graph that looks something like this. So since logarithms and exponentials are inverses, the asymptote just moved. So now it looks like the graph is approaching this line, which is the line x equals 0. So that is where my asymptote lies. So the asymptote here is at x equals 0. The domain. So it's probably easier to look at the graph. So you can only choose positive values of x because this asymptote keeps you from choosing negative numbers back here because you can't take the log of a negative number. So your domain is going to be x is greater than 0. Your range, turns out your range is going to be all real numbers. So this is going down to -infinity. And it's going to keep going up and up and up ever so gradually. But that one is all real numbers. So that would be how you graph a log of 3. Let's see what the graph looks like when it's a fraction like 1/3. I'm going to first switch it into exponential form. So when I drop and swap, I have 1/3 to the y equals x. I'm going to make my table of values. So since my y is in the exponent, I'm going to choose y values in this case. -2 to 2 will work. So I have 1/3 to the -2 power. You can either remember negative exponents or you could put that into your calculator, and that would be 9. I have 1/3 to the -1 power. use negative exponents, that would be 3. 1/3 to the 0 power, anything to the 0 is 1. 1/3 to the first is 1/3. And then 1/3 squared would give you 1/9. So here are my values that I'm going to plot. 9, -2. 3, -1. 1, 0. That seems to be pretty common on both of them. Estimate 1/3 1 and 1/9 2. So you sketch it in, and your graph should end up looking something like this. So the one thing that they have in common is their asymptote. I have an asymptote at x equals 0. So it's approaching this to positive infinity now, but never ever going to cross it. So I have an asymptote at x equals 0. The domain is still going to be the same, so you still can't take a log of a negative number, so we don't have any negative values. So x is going to be greater than 0. As we do shifts and transformations in future sections, this asymptote and the domain numbers are related. They should be the same. And then the range. You could still go to positive infinity, and that's going down ever so slightly. So your range is going to be all real numbers. In the next section, we're going to figure out how to do transformations. See you in a minute.